Hello, class. Welcome back to Global Climate Change. Today, we're going to be going over our mitigation strategies, specifically having to do with the transportation sector. So, this is quite a long chapter, as you can see. I have the whole chapters reading down here. I kind of tried to cut out some of the parts of this lecture that weren't extremely important because it is such a long lecture. So please do what you can to read chapter 7 of the book. I will try my best to keep this lecture, at a reasonable length. That being said, let's just get right into it. The first step in most rehab, scenarios is to admit that you have a problem. And with respect to climate change, I don't think that at least the United States is completely there yet. I can tell you, being from the Midwest, sentiment regarding climate change is different there than it is here. A buy-in is not complete there, and a lot of people don't really understand, the carbon cycle or how, carbon actually is a selective filter, or carbon dioxide is, to our incoming rays. A lot of them, I've heard a lot of people say that they thought it was just a normal cycle, that the Earth goes through. So I guess that we're in some parts of the country, and some people are still in a state of denial. And this denial has slowed many attempts at intervention. But after the buy-in is there, and after the majority of people, at least, vote towards the fact that yes, we think climate change is happening, and yes, we think something needs to happen towards this. The next step is going to be a mitigation strategy. So this lecture right now is on a mitigation strategy on the transportation sector, and then next week will be energy, how we create energy. Okay, so we have fossil fuels here, and we kind of have it broken down a little bit. First, extraction and combustion of fossil fuels account for 65% of greenhouse gas emissions from human activities. So, our vehicles, our electricity, how we're powering our electricity, all these things like that makes up 65% of the emissions, with the remaining 35 coming from changes in land. So, deforestation, forest fires, burning trees, things like that, and agricultural sources. So, the production of different crops. This provides 84% of the world's total energy production. Virtually all of energy for transportation is used by fossil fuels. So, what does this mean? This means that even if we have complete buy-in and everybody's on the same page, if we banned fossil fuels tomorrow, the world would stop. Nobody would be able to move around. Everybody'd be stuck where they were. So we need to think of other ways of, transporting people, or at least other energy being used in order to transport people to be able to effectively actually mitigate climate change with respect to transportation. So, energy consumption increased over the past 30 years. Global energy usage has increased by about 2% per year. Now, this is due to population growth and economic development. So, if you think about it, as the population grows, the more we're going to need to move around. The more people will be flying, the more people will be buying cars, the more people, will be taking buses, things like that. And also economic development, that means we need to provide energy for more buildings and, energy for more transportation to ship goods around. But there's not much change in energy usage per capita. So we'll go over this here in a minute, but there's total energy usage, but there's also total energy usage per person. So I may use energy differently than you use energy, and somebody else might use energy different than we do. And somebody from a different country might use energy completely different than us. So it's important that we look at per capita as well, because are the people using more energy per person, or are they using the same amount of energy as we are to power or to support more people? So all these things kind of go into factor, which is interesting to me as a data scientist as well, because I do have a background in data science. So when we look at these numbers in different ways, we can explore different ideas with respect to the data. So, over here on these graphs, we have greenhouse gas emissions on the left and energy consumption on the right. So you can see that the CO2 fossil fuels make up the majority of the carbon emissions. Some of it is land use, some of it is CH4, some of it is different things like that. But if you go over here and look at energy consumption, if we look at coal and petroleum and natural gas, I mean, these are like by far, and look at how much, some of these are going up, here since like 2003, they're going up at quite a bit of a rate here. Hydro, nuclear, biofuels, things like that, they're going up for sure. But they're just, look at this. The hydro is just the same sector. It doesn't really change the percentage of the energy. And we'd like to see this a lot bigger than it is. Even the biofuels would like to see this a lot larger of a percentage of the whole. Okay, so this is going to be, and remember I was telling you this is going to be per person or per capita. So, this is going to be per person, um, how much energy is consumed. And the United States is above everyone else. Look at China. China is way down here at the bottom. I mean, it's definitely, it's getting larger. But consider the amount of people that live in China. Right, there's so many people. I was in China a couple of years ago, and it's just astounding as to how many people really do live there. I don't think you really can fathom it until you actually go there and see, being shoved into a subway or, sitting in and eat at like McDonald's, and everyone else just comes and sits next to you because there just isn't a lot of room there. So, the United States, like considering how many people they have, they're not really using that much energy per person, where we have less people, but each person is using a lot more energy. California, I think that you guys here, us here, are very, very, I want to say, aware of how much energy we're using. But in other areas of the country, I'll tell you, it's not something that's on the forefront of the people's thinking. So here's the energy consumption per GDP. We can see here that China is the highest, but it's going down. Look at they're definitely going down here. The United States is going to be second to that, with Japan being the lowest amount. So it's good that it's going down. I think we're going down a little bit here, but not as much as we'd like to see. The world is kind of staying the same on average. Now, this graph ends right about 2013, and things will change again due to certain policies, actually, that's went into effect in our current administration. So if we were to look at like 2016, 2017, 2018, this graph would look a lot different. Those numbers are hard to get a hold of, though, because they're just hard to get a hold of. Okay, so transportation. The globalization of the world's economy requires that humans and products move long distances. So we ship a lot of our products from, overseas, Hong Kong, China. We get a lot of our products from, just some in Mexico, different places like that. So we've got to ship them, over the distance of the ocean, or we got to, truck them up from Mexico, wherever we might receive these products, because we're definitely a nation of consumers. It requires, energy to get it to us. Passenger and freight travel will increase greatly during the next 50 years. And this is partially because of the increase in population. There's going to be more people, there's going to be more travel. But if there's also more people, then there's going to be more consumption as well. And so there's going to be more, things that are going to need to be shipped to us. We export a lot of goods. Import a lot of goods. So, that means that a lot of these goods are going to have to get to us. As our population increases, we're going to just want more things. Argos. Okay, so this is going to be kind of like an idea of how our travel is actually increasing over time, and how each country or area actually is going to move around. So you can see that West Europe does quite a bit of travel. So does China, but North America, I'd say, is going to be the largest of this, the travel that's actually done. Russia is not. Where's Russia? Russia's down here. Okay, Africa obviously is, not too much here. Let's see, who else do we have? India. There's a little bit of travel here. Southeast Asia. But it's definitely increasing for China. It's definitely increasing for North America. I would say that Western Europe has a little bit of an increase, but over time, all of them are increasing. But everybody's travel's gotten a lot easier and more accessible to more people over time. And this is freight travel. So this is human travel, and this is going to be freight travel. So this is how we're shipping our goods. You can see a lot of goods are being shipped, especially here, out of China. They produce a lot of things in Guangzhou, Shenzhen, places like that. They ship out of Hong Kong. Over here in Russia, there's not too much of a growth there, not too much of a growth in Western Europe, but you can see a growth, I'd say, in China, in North America, quite a bit. Oh, Russia, there's a little bit of growth there. You can see that. Who is this? The Pacific, there's not very much growth there. And the Middle East. You can see some growth, though, here in Latin America. Okay, so petroleum. Currently, the overwhelming energy source for travel, 90% of it is actually from petroleum. The top three producing countries are Saudi Arabia, USA, and Russia. So, Saudi Arabia, USA, and Russia, a substantial amount of their GDP, or at least a percentage of it, will come from, exporting petroleum. How many years of oil is left in the world, though? It's definitely a resource that is finite. So, once it's up, it's up. So this is going to be production by region here. You can see North America, we've kind of had a steady production. It's going to be going up, and then the last few years, if we were to kind of have more recent years in there, you can see right here South and Central America, it's kind of going up. Europe and Eurasia is kind of staying somewhat the same. Middle East is going up for sure, and here in Africa it's going up as well. So you can see that the percentages are kind of going up, but most of the petroleum production is done by the Middle East. Okay, so 14% of global emissions come from transportation sector. 28% is in USA and 7% in China. Light duty vehicles, freight trucks, and airplanes contribute the largest shares. So, things like, I want to say like Hummers, these trucks that you'll see people driving around. Unfortunately, in the Midwest, so many people have them. That's going to be a large percentage. Also flying, people flying around. Lower total emissions from boats, trains, buses, and motorcycles. So those of you guys that, take the train to school or to work, those of you guys take the bus or even ride a motorcycle, you guys are, doing really well, with respect to emissions. But like for me, I have to drive in because of the time that I come, just because of certain other factors. I'm trying to transition over to using the train and getting my timing correct, but at this point I haven't gotten there yet. Actually, I'm looking to move a lot closer. I'm looking actually to move close to school, so that way I don't have to drive into school every day. See, and these are things that we can do to change our lives in order to, make it to where we're not emitting as much or our carbon footprint isn't as large. Okay, so here is going to be, by different type of transportation, the emissions here. And you can see light duty vehicles is by far the largest. And right under that's going to be, freight trucks and then airplanes. Water, this would be boats, freight and passenger rails. The 2 and 3 wheelers is like just a small percentage. Buses is just a small percentage here. So, we really, really got to try to get these light duty vehicles and the freight trucks on some sort of alternate energy source in order to really help with this. Light duty vehicle, by the way, is defined as any motor vehicle with a gross vehicle weight rating of 10,000 pounds or less. So that pretty much is any one of our vehicles. If we drive one, that's what we're going to be driving. I guess if it's gas powered, I should say that caveat. Okay, so this is going to be like what the transportation sector uses to for energy for their to move around for transportation, and this is going to be the energy used by type. So obviously light trucks, like we said, cars and motorcycles are less than that, but light trucks are by far the highest. Other trucks are like kind of right underneath the cars and motorcycles. Aircrafts are going to be quite a bit behind it. So if we could get these cars and light trucks and other trucks kind of on some sort of alternate energy usage, look, these are not as much. They don't make up as much, and most of them use gasoline or petroleum. If you look, or petroleum over here in jet fuel. So the largest percentage of this pie is all going to be fossil fuels that it uses for energy or for Okay, so fuel efficiency. Fuel efficiency is defined by the distance traveled divided by the volume of gasoline required for that distance. Okay, so it's commonly measured in kilometers per liter, which is most of the world, or we use miles per gallon. So for light duty vehicles, which are the ones that are most of the ones that are contributing towards climate change or contributing, the CO2, this varies by regions of the globe, and there are a few factors that affect fuel efficiency. Okay, so driving conditions. So like if you're in a traffic jam, you're going to use more, or versus a highway. If you're in a city versus if you're, in a rural area. Taxes on petroleum and vehicles. So here in California, the taxes are really high. So our gas is really high, which forces more people to use the train and the buses, which is, a good thing because then we have less of a carbon footprint. We have consumer preferences, use of diesel. Consumer preferences, by the way, I kind of tell you guys there's a lot of people have trucks, in the Midwest, but they kind of need that. They have, larger families. There isn't any public transportation in Omaha where I'm from. There's simply, you can't use it. And if you can, it takes like basically I see. I took the bus one time from one end of town to the other, and I think it took me like 4.5 or 5 hours. So it's just not good. Like there's no way to really feasibly use it. So that's where most people will own cars and they don't use public transportation in these areas. So then the use of diesel powered vehicles. So how many people are using diesel? Also, automobile manufacturer agreements. So there's going to be more. We'll go into this here in a minute, but there's going to be agreements with the manufacturer and the government as to like how they're going to be reducing emissions throughout time. So those types of agreements will also affect fuel efficiency. Because I know when I started driving, my car didn't get half as good a gas mileage as my car right now that's newer. Okay, so as of the early 2000s, fuel efficiency in France, Germany, and the UK was 29 to 32 miles per gallon, and it was 20 to 22 in US, Australia, and Japan. So you can see, this is going to be the year, and this is miles per gallon over here. So you can see right here, where's the United States? It's in this kind of reddish color right there. You can see it's kind of right around there, 20 to 22 mile per gallon. Now this is as of, let's see, the early 2000s. So I'm sure we'd be higher up right now, into here. But, Germany, France, and UK definitely are aware of climate change and they're doing a lot to try to mitigate it. So I'd like to see a current one of these graphs actually to see where they're sitting as well. Okay, so this is gonna be in relation to speed. Remember, I was saying if you're like in a traffic jam or something. So, due to increased wind resistance at higher speeds, fuel efficiency decreases at speeds above 50 miles per hour. So, vehicles traveling at 75 miles per hour are 20% less efficient than those at 55 miles per hour, which is kind of insane if you think about it. This is the reason why they started having the speed limit at 55 mile per hour. This is during actually the oil crisis in the 70s. They made the speed limit at 55 so that all the cars on the road would be getting the most efficient gas. I'm sorry, fuel efficiency at the speed that they're driving. And also, like I was just saying, my newer car gets better gas mileage than my older one. Newer vehicles have better aerodynamics and are more efficient at higher speeds than older vehicles. So this is kind of interesting as well. I mean, I know my first car was like a 78 Chevy Malibu, I think it was. It was old for when I bought it, okay? So I'm not that old. But, it was really boxy and it was a station wagon. So it was like grocery getter, but right now I drive like a Buick and it's a lot more rounded, so I would imagine that my newer car right now has way better aerodynamics than the older grocery getter that I used to have. Okay. Oh, and this goes over to the response to the 1973 oil crisis. This is when they set the maximum speed at 55 miles per hour. This was designed to reduce oil consumption. Okay, and then also remember I was saying about the traffic jam. So quick acceleration and heavy braking decreases fuel efficiency by 30%. Automobile companies advertise two efficiencies for each car. So those of you guys that went out and bought a new car, it actually does give like the city and the highway miles per gallon because they are so much different from each other. They're not the same. And due to the number of cars increasing faster than road capacity, congestion is rising. And since we live in the Bay, if anybody also is from SoCal, the LA area, then they will definitely attest to the amount of, gas that they might be using while they're just sitting, like going, stopping, going, stopping. You actually use more gas at the end. The best case scenario is just to be sailing at 55 mile per hour. as far as fuel efficiency. Okay, so taxes. Remember, I was saying that taxes actually will affect how fuel efficiency because the average cost of extracting, transporting, refining a gallon of gas was $2.01 in 2006. Average price of gas at the pump was between 8 cents and $7.19 varying by country. So this is like all over the world. This depends on subsidies and taxes. So major oil export countries tend to subsidize fuel and others tax fuel. So April 29th, 2019, the U.S. gas price was $2.88 per gallon, which was very close to what it was in Nebraska. And in California, it was $4.08 per gallon. So I will tell you guys that we used to have two vehicles, and one of them was a Jeep that was full-time, four-wheel drive. Obviously, in the Midwest, you need to have four-wheel drive, but it got about 10 to 11 miles per gallon because it was full-time. And so we actually ended up selling this car after we got here because we're like, we can't afford the gas. It's just so much money to drive around in this car. So those types of decisions that people make is part of the reason for the taxes. They want people to make decisions based upon, how much it costs to drive around. So there's going to be different countries that put taxes or subsidize fuel. So these will be the ones who subsidize it. You can see how it's Egypt, Algeria, Jordan, Saudi Arabia. These are some places that, actually end up producing fuel. Over here you can see ones that will tax it. Here's the United States right here. It's 12th. This is the percentage, 12%. Let's see, Norway, Morocco, here's South Korea at the highest taxation. And then in the US, gasoline prices vary greatly by state due to tax differences. So here's Nebraska right here. It's in the yellow, almost green right here. And look, all of California is in the deep red. Sorry. Okay, so here's going to be the production share. This is going to be pickup trucks, minivans, SUVs, crossovers, and cars. So how much of it is actually being produced in the United States, throughout time. So, you can see that pickup trucks, is about, I don't know, what's this, probably 15% or so of the share, where minivans, it's definitely gone up here in the 90s, and then it kind of went down here as well. SUVs, though, skyrocketed, but there wasn't really SUVs in the 1970s. I mean, and then crossovers, they didn't exist. So that's where, these kind of come in. So more cars were being produced right here in like 1980. We can see some dips down here, which is probably when we had gas, gas prices, gas wars and things like that. You can see kind of the rise in trucks and minivans right here in 1994. So definitely, it's changing throughout time. Now we can actually, we went over gas powered vehicles. Now we can go over diesel powered vehicles. Diesel is denser than gasoline and contains 11% more energy per volume. Diesel engines are more efficient than gasoline engines in converting fuel energy into mechanical work. So you get more miles per gallon basically out of a diesel engine. They obtain about 40% higher fuel efficiency per volume, and small diesel engines have been plagued with performance issues, though, because you might be sitting there thinking, well, if that's the case, then why don't we just flip everything over to diesel? Well, there's lots of issues with diesel engines. They're noisier, they generate more vibrations, they're more difficult to start. There's actually more emissions of black smoke in their exhaust, and they exhibit slower acceleration. So you get, 0 to 60 faster in your car or your gas powered car than you do your diesel. Okay, so, this is transportation efficiency regulating automobile manufacturers. So the U.S. enacted corporate average fuel economy, which is the CAFE regulations. This is going to be basically where a fleet must meet minimum average per value. So like in 1978, it must hit about 17.2 miles per gallon, where in 1985, new cars had to be about 21 miles per gallon. This is a controversial subject, and actually President Trump froze this regulation, so I'm not sure exactly what's going to happen throughout time at this particular point, because California is kind of Governor Newsom is kind of fighting President Trump on this. So we'll see what happens. We do have the highest population. Of any other state in the union. So we do have quite a bit of pull when it comes to things like this. So, hopefully that freeze will be lifted, because these regulations, as we just stated in the past, regulations and taxations and things like that actually affect how much people drive and what the miles per gallon end up being. Okay, so this is going to be the carbon emission intensity per different type of transportation here. Helicopter and taxis and limos being the highest percentage, where cruise ships are kind of after that. And then, this is the United Kingdom and United States. So you can see personal truck is kind of, and we already said that, it's going to be the highest out of any personal type of thing that we use, with car being right underneath that, and then airplane being under that. But helicopters and taxis seem to be the highest carbon emissions intensity. And this is going to be public transportation. So this is going to be obviously the number of people which use which one. So this is going to be other, the red is public transport, and then the green is going to be carpool, and the brown is single occupant vehicle. People just like to drive the cars, and that's fine. I'm just saying that look at how much more. But there's so many parts of the United States that public transportation isn't even accessible. You can't even really use it. So really the big cities are the places that I know of, and even a lot of the big cities don't have really good public transportation. The best public transportation I've seen actually has been overseas. Once I think we actually start looking at our public transportation and how to make it more efficient for the people to be able to use, then hopefully this graph would change. But at this point, like I said, if it takes you 4 to 5 hours to get where you're going, it doesn't even make sense to try and use. Okay, so once global peak oil has passed, half of oil ever available will have been extracted and consumed. Production will then enter a terminal decline and the cost of it will increase. So it's important to look into alternative fuel sources for the transportation sector. I mean, as well as just because of climate change, we don't have like just infinite number of oil or coal, or I want to say carbon in our Earth, where it's finite. So we got to find something else to do once it's all used up. So we have a couple of alternative fuels that we can use for transportation. The U.S. Department of Energy has set a 30 by 30 goal, so 30% of gasoline used from alternative fuels by 2030, so that's about 10 years away from now. So alternative sources for transportation would be natural gas, hydrogen, electric, hybrid, and biofuels, and we'll go through each one of these. So natural gas is extracted from oils, wells, coal beds, natural gas fields, and landfills. Okay, it's made of hydrocarbons and releases CO2, so it definitely has a carbon footprint and contributes to climate change. It compared to gasoline, considered clean burning for transportation because it produces 80 to 90% fewer aerosols. Okay, so it doesn't have as many aerosols, but emits 12% less greenhouse gases as well. So it's the better of the two alternatives. Low density presents transport challenges, mainly U.S. pipelines near capacity. Or many U.S. pipelines near capacity. We're at the point where we're not going to be able to be using natural gas very much more. It's harder to move around. It's heavier. We have to have these bigger tanks. So it's not as feasible as, gasoline. But LA's been using it. So this is carrying a sufficient amount of natural gas to power a vehicle. Any distance would take a huge storage tank, which is what I was saying. Therefore, natural gas is pressurized to 136 to 245 atmospheres. You can see, up here on the top is where these tanks are. And it represents a cleaner alternative to petroleum, but still a non-renewable resource, like we kind of were going over. And you can see that in the Asia Pacific are the ones who really use it the most, and they really started using it right around 2005, 2006. North America is right down here. We don't, we're pretty much staying the same as Africa is. Europe is kind of using it a little bit more, and so is Latin America. Okay, and then the next alternate would be hydrogen. And this is the 2003 State of the Union from President George Bush. He basically says a simple chemical reaction between hydrogen and oxygen generates energy. He goes on to say, with new national commitment, our scientists and engineers will overcome obstacles by taking these cars from the lab to the showroom. So the first car driven by a child born today could be powered by hydrogen and be pollution free. Technology has not progressed on this optimistic timeline, which is interesting because I'm pretty sure he got all of his money in Texas from oil wells, and he was a proponent for hydrogen. So good for President Bush. So hydrogen, there's reliability. They're extremely sensitive to external temperature and moisture, so it's not very reliable. With respect to production, it's not an energy source, but an energy carrier. There's no recoverable deposits of hydrogen, and 95% of it is generated today, derives from fossil fuels. So it's still a fossil fuel. Storage, the hydrogen has the lowest energy content per unit volume of any fuel. And it needs to store a lot in the vehicle, which presents a technical challenge. Like I said, you have to have these big barrels, right, in order to carry it around. So, that would make the vehicle extremely heavy and cumbersome. They wouldn't be able to be like, as aerodynamic and it just isn't as feasible. And fuel cells require extremely expensive compounds. Many components cost more than their weight in gold. So it's not cheap. It's going to be extremely expensive to have a hydrogen powered car. So as much as it's a great idea, it isn't really as feasible as we might have thought in the beginning. So another alternate fuel would be like, electricity. Electric motors that require only charging, not refueling. Challenges are limited distance and speed. Speed isn't as much. I've test drove a Tesla with my neighbor recently, and we were really surprised at how fast it actually is. There's high recharge times. That's getting a little bit better as well. And the cost again is getting a lot better. Elon Musk said that his new Tesla would be 35,000. I think it is. But we also have the carbon footprint of the batteries. We have to produce the battery. We have to, to figure out how to dispose of the battery. So we can't forget about that either. But the benefits are they don't emit greenhouse gases directly, only indirectly. They don't release any aerosols, and they save money on gasoline, right? So a lot of people, and plus, I guess you get to use the carpool lane as well in this area of the country. Then we also have hybrid electric vehicles. These are both gas and engine, gas and electric. So the gas engine charges the battery. The gas engine shuts down when the vehicle stops, and it uses regenerative braking. So the braking actually is going to charge the vehicle as well. And the hybrids improve fuel efficiency by about 30% in city driving. Because if you're like going and stopping, and then you're stopping and stopping actually like is going to charge the battery, then stopping isn't so bad anymore. And then we also have biofuels. Biofuels are produced from living materials. Most modern engines have flexibility to combust mixtures of biofuels. So like ethanol. If you guys ever look at the ethanol percentage in your vehicle or in your gas, that's going to be like a percentage of biofuel. And it's basically from corn. So being from Nebraska, the corn husker state, there's a lot of corn in Nebraska. And I can tell you about, when I first moved there from New Jersey, I was shocked because I thought I could just go outside and like eat some of the corn. And that's not true. Like almost 90% of the corn that's grown in Nebraska is either grown for energy or for consumption for the cattle and the pigs. So for, obviously for food, for the food, I guess. Food for the food. Anyway, so basically, biofuels can help, when we mix them along with gasoline, to try and mitigate some of this CO2 emissions. But the problem is that actually these are the benefits here, has about a third less energy content per volume. E85, which is 85% ethanol, 15% gasoline, is less expensive, has lower fuel efficiency than gasoline, helping to negate lower CO2 emissions. Okay, so it actually has, less fuel efficiency. Let's see. Okay, it actually, but I was just going to say, you might think that's a great idea, but in practice, biofuels have a large carbon footprint. So, there's machinery, fertilizers, pesticides, and water that go into growing the plants, and then we have to transport the plants into a place where it can be processed, and then the processing takes like a lot of energy and in order to process it as well. So, and then because we're, like I said, we're not growing the corn to feed people, or as feed for the animals, then it's diverting the food to the fuel, and it raises the price of food, because of the fact that there's not so many corn plants anymore. So biofuels actually have been found to be not actually as good as we originally thought, even though we use them a lot. The last one is the idea of a nuclear powered car. We don't have these, by the way, so don't think that you could go out and buy one, but this is kind of an idea that's been tossed around quite a bit recently. And if we were to have nuclear powered cars, the benefit would be high energy per volume. We could travel far without needing to refuel, but the challenge is going to be radiation exposure and the weight of, this thing that's going to, power the vehicle. I'm assuming this is what it is back here in the back. So there's definitely challenges to overcome for this. I guess the big takeaway from this lecture here is there isn't like a clean cause. There isn't really the best case scenario. If we're going to be moving around, the best way to do it is to be walking, biking, using something that doesn't even take energy other than from ourselves, and then we'd be healthier anyway. Public transportation, getting better like areas or better ways of moving around, because like I said, right now there's many areas of the country where it just isn't even feasible to use if there is public transportation, and there's areas that there isn't even public transportation. So we need to work on our public transportation and possibly getting that into like electric, or some other alternate form. I know that, like I said, I was in China, in Shenzhen. They actually, all the government vehicles, all the buses, all the taxis, everything is all electric. So they're really trying to stop pollution, and they're really trying to, do more with respect to climate change. So they actually, their whole city, which is blown up, like Shenzhen has grown much in like 30 years. It went from a little itty bitty city to like a huge city in 30 years. So they are using actually more I say more renewable resources to actually power their vehicles. So, that would be really good if we could kind of use that for our public transportation over here as well. So this actually is the last slide in our lecture, and I hope you guys have a great week. Thanks for hanging in there. Bye.